Good evening, students. I miss seeing you guys. This is sort of the only way I can think of doing the midterm review, so we're going to go over it page by page. I'm probably going to do about an hour of it, and then I'll have a separate one wherever we end up, so it's not continuously talking about this, but I'm hoping that you worked on this midterm review. If you didn't, work on it as we go, take the notes, and we're going to use some of this for your certification exam studying and for your final exam. So make sure what I'm talking about, you write some type of thing other than it might be in addition to what the definitions are, but they'll help you further later on with your, again, your certification exam and your final exam, because some of this will be on the final exam too, but you will have a review packet for that. You will not have, so Tuesday is going to be your midterm, and then you will not have your next Medlist quiz until the following Thursday. So actually a week from today will be your next Medlist quiz, depending which one you're taking, and Tuesday is going to be our midterm exam. Now I know some of you have increased your hours at work because of all the COVID-19 things, and so it might not be feasible for you to be able to sit down and take the test at 5:30 on Tuesday. So just reach out to me, email me at my COD email address, and tell me when you want to take the test. I don't have a problem with you taking it at a different time, so just email me that and we can adjust it. The rest of you, I'm going to open it at 5:30 next Tuesday, and then you'll have the full 3 hours to take it. So I think we'll do 5:30 to 8:30, even though we changed the course time. I think that'll just be easier to make sure you're hopefully done with dinner and you can just sit there and take it. It is not going to take you 3 hours, but I have to give you the same amount of time that we would for the normal class time to take it, and it'll be submitted on Blackboard, so it'll be electronically submitted, so you don't have to email me anything, any paper, unless something crazy happens and we can't submit it. But I think it'll work out okay. The other thing is I will be able to you'll be able to look at how you did. There is a way to get in Blackboard under my grades to look at how you did on the test. Maybe some of you already use this function in your other classes, but they told me there is a way for you to look at it that way, because normally I give this as a paper test. But when we do come back, and hopefully we will be coming back together again before the end of the course, I will give you a copy of both the midterm exam and the final exam, so you have a paper copy. So you can have the questions and, again, use it as a review for your certification exam. One thing I want to correct on the midterm review right here is number 1. I just noticed it's 2 teaspoons equals how many mLs equals, and you should have, that should be a dram sign. When I first did this, I didn't have the dram available, but that should be a dram. So I want you to do all these conversions on your own, and then I will give you the answers for these later on, either tonight or tomorrow. I'll post those. So you should be able to do these without your conversion sheets. Hopefully you can do them either by memory. Most of these are conversions that you should have remembered that I told you day 1 you needed to remember. The only one might be the grain one, but think about what we did. And for the grain one, for number 5, I want you to use, let's use 65 milligrams for 1 grain. Okay, we'll do that for number 5. Anyways, everything else you should remember. If you don't, then go back to your notes, do the calculation, but then star that once you remember, oh, I need to remember that conversion factor. All right, the other thing is kilogram to pound, pound to kilogram. Make sure you can do those conversions. Remember, it's 2.2 pounds per kilogram. So normally we're dividing by 2.2. In real life, we're always dividing the patient's weight in pounds by the 2.2 pounds per kilogram. Now, if we want to So in real life, we're always, remember, dividing the pound weight by 2.2 pounds per kilogram. And whenever we have these problems, say when they ask for the milligram per kilogram dosage for a patient, we have to, very first thing we do is convert those pounds to kilograms. All right, so under SIG codes and abbreviations, you need to think about the quizzes that we've had so far on your SIG codes and look over those. Look over the ones that I gave you day 1 that were the frequency ones, PC, AC, the ones for eye and ear, so AS, AD, AU, OS, OD, OU. So again, think of PC, AC, PC being after meals, AC before meals, eye, OU for both eyes, OD for right eye, OS for left eye, AU for both ears, AD right ear, AS left ear, PRN for as needed. These are all the ones you need to make sure you know. And also know frequency for number of hours. So Q4H meaning every 4 hours, Q8H every 8 hours, and be able to convert that into how many times a day. So Q8H would be 3 times a day, Q6H would be every 6 hours, which would be 4 times a day. All right, so now on to these definitions. And I'm going to talk slowly so you guys can write things down, and I'm not going way ahead of myself. And if there is a question about something, feel free to email me, and double check on it, ask about it. I'll be watching my emails over the weekend and tomorrow after this is done. So just, make sure if you have any questions to reach out to me. Okay, so for Hipaa, I'm not going to ask you to define what it means, but it is Health, Insurance, Portability, and Accountability Act. So again, Health, Insurance, Portability, and Accountability Act. And what the meaning is, we need to protect a patient's information, keeping everything confidential. So remember privacy. Think of the Privacy Act when you see Hipaa. And what goes along with Hipaa is 2 more down, PHI. So for PHI, we want to remember that's protected health information, protected health information, and it's in all forms, written, verbal, and electronic. OBRA is the Omnibus, OMNIBUS, Budget Reconciliation Act. Again, I'm not going to ask you to write out the meaning, but I just want to make sure you know what it is in case it's like on your certification exam. Again, we're going to keep this, and we're going to look at this before we take our certification exam too, as a resource. Again, Omnibus Budget Reconciliation Act, or OBRA. What's the meaning? It's patient counseling on all new or changed prescriptions. So that means that we are going to talk to the patient, the pharmacist, not the technician, the pharmacist is going to talk to the patient and counsel them about their medications, how to store it, how to take it, what to do if they miss a dose, what the side effects are, all those types of things. So again, how to take the medication before meals, after meals, if they need to cut it in half, be clear on what their dosage is, what they should and shouldn't do, what side effects they may encounter, storage requirements for it. Those are some of the points that they need to cover on the counseling points. And we do this for all new or changed medications. We do not need to do it on refills, so make sure you put that on there. We do not have to do this on refills. Even if they've been on the medication for a long time and it gets changed, say they've been on the same strength of, my example always is metoprolol, and 5 years later it gets changed to a higher strength, that would be considered a new prescription, or essentially a changed prescription, and we would have to counsel them on that. Okay, Ptcb and Ptce, remember that's the Pharmacy Technician Certification Board, and that's the Ptcb. Ptce is the Pharmacy Technician Certification Exam. So that's what you're going to take when you finish the class here. So the Pharmacy Technician Certification Board, or Ptcb, certifies technicians, and then they administer the exam. I'm going to pause a little bit in between each one so you have time to write things down, and I'll repeat that again. Pharmacy Technician Certification Board and the Pharmacy Technician Certification Exam. certified technicians. You have to go through them to make sure your certification is, you have to verify your certification with them every 2 years, remember, and that's through your 20 hours of CE that you need every 2 years. Okay, the Orange Book is made up of therapeutic equivalents. So this is what we use for generic substitution. So again, the Orange Book is made up of therapeutic equivalents, and we use this for generic substitution. And we talked a little bit in class about the ratings, that they can be A-rated, drugs can be A-rated, B-rated, or AB rated. I think we get a little more into this in the second half of the quarter. We do that, I forget which chapter, but we'll talk about that a little bit more, but it has to do with if the drug is actually a therapeutic equivalent and if we can substitute the generic for the brand name if it is therapeutically equivalent, and that's what the Orange Book is. Like I told you, the Red Book and the Orange Book, there are always questions on the certification exam on these. And the Red Book lists prices. It lists the average wholesale price, or AWP. So again, it lists the average wholesale price, or AWP, which is the cost of drugs. Oopsies, hold on. Sorry about that. The USPNF is the United States Pharmacopoeia, that's PHARMACOPOEIA, United States Pharmacopoeia National Formulary. So then the USP part is a book of standards, okay? And it's standards for manufacturing medications, for compounding products, and we've talked about the 3 chapters in there that we need to pay attention to. For compounding in pharmacy, we need to pay attention to Chapter 797, Chapter 795, and Chapter 800. So the 3 chapters we need to really pay attention to are 797, 795, and 800. There are monographs also included in the USP, drug monographs, which describe the drugs. The NF is the National Formulary, and that lists excipient agents. EX, CI, PIENT, these are inert ingredients, so the inactive ingredients that are added to the drugs, the dosage form. Remember the other day we looked at tablets, and there was a big picture of a tablet with a corner of it taken out, and they cut into it and showed you that not all of it is the medication. It's also possibly waxes, other kinds of fillers, sometimes sugars, lubricating agents, all different kinds of things to make that tablet to the size where someone can actually handle it, and so that it has the properties of whatever it needs to do. So if it's long-acting, it has to have different excipient ingredients in there to make it a long-acting tablet or capsule, say. So just so that you know, it's inactive ingredients, they're called, or inert ingredients, they're excipient agents. So that's within the NF. And what the USPNF does is these standards ensure that products are all made to stipulated strengths of quality and strength, and that they are of quality and purity. So they reach the standards that we want in the United States of quality and purity. Yes? Sorry about that. The next one is the Handbook on Injectable Drugs. That is Trissels. And then there's another injectable drug book called King. So I would know them by the author's names, because that's how they usually refer them. But this resource or reference would be used in either one of them would be used in hospitals for compounding sterile products or IVs. So the Handbook on Injectable Drugs is Trissels, and then, like I said, there's a separate one that is popular, and the author is King. Again, this would be used in a hospital. It would not be used in a retail setting. The PDR is the Physician's Desk Reference. Physician's Desk Reference. And if you can remember that this is made up of package inserts, so those little inserts that are on the top of the bottles when we get them from the manufacturers that have all the information you need to know about a drug, that's what this book is made up of. Again, that was the Physician's Desk Reference. Drug facts and comparisons would be used both in a hospital and a community pharmacy setting. It's a more concise reference than, say, using the PDR. You can quickly look up the drug's dosage, what dosage forms are available, side effects, strengths, things like that, quickly and easily, but it would be used, again, in a hospital setting or in a retail community pharmacy setting. All right, we're going to go to the next page. And drug schedules. So remember, the higher the requirements and controls is, the smaller the number. So a 2 has more potential for abuse than a 4. A 2 is the highest as far as the restrictions on those drugs versus, a 3, a 4, a 5. As we go up, the restrictions are less and less in number. So it's sort of the opposite of what you would think. So for 2s, the main class are narcotic analgesics. Okay, so that's the main class. And if you look in the day 1 packet, I gave you, I think there were 2 lists of different drugs per class. But for some examples here, on this one, I would say oxycodone, which is OxyContin. So oxycodone, the brand is OxyContin. And again, you can look at that sheet. And I also put it in the law review. That was about 4 pages that I gave you. There's also a list of the scheduled drugs in there. So, and if you need the spellings, you can get them off of there. The second example I would say is hydrocodone / acetaminophen or APAP. So any hydrocodone product, but the most common are hydrocodone with Tylenol. And remember, the abbreviation for Tylenol is APAP. The brand names for that would be either Vicodin or Norco. But anything containing hydrocodone is a Schedule II. Another example of a Schedule II would be morphine. And last, another example would be oxycodone with Tylenol. So the same as oxycodone I gave you previously, but we added Tylenol with it, so with APAP, and that's Percocet. Another class that's in the Schedule II, is a different class, are amphetamines. And these are drugs that are used essentially for ADD and ADHD. So amphetamines for ADD and ADHD, which is attention deficit disorder and attention deficit hyperactive disorder. And the examples are Ritalin, Adderall, and Concerta. I'm not going to make the generics on those. We've I think you had those already, but just we'll put the brands for those 3: Ritalin, Adderall, and Concerta. A couple things to know about Schedule 2s. There are no refills allowed, and the patient can only get a 30-day supply. Now, this is an Illinois law, but they can only get a 30-day supply. And the prescription is good for 90 days from the date of issue. So whatever date it was dated, it's good for 90 days from that date. All right, the second drug schedule are the Schedule 3s. And one of the classes would be the anabolic steroids, like I mentioned in the beginning of that question. So anabolic steroids, like testosterone, would be a Schedule 3. I think we had Androgel was our drug that we had. And we have also any of the Tylenols with codeine would go in this category. They're all Schedule 3s. So Tylenol number 2, Tylenol number 3, and Tylenol number 4. Those would all be included as Schedule 3s. And remember to write those generically. We write APAP with codeine. And then I think you should know the amount of codeine in each of these. That question has come up on the certification exam, and I did go over this with you one day in class. So a Tylenol number 2 has 15 milligrams of codeine per tablet. Tylenol number 3 has 30 milligrams of codeine per tablet. Tylenol number 4 has 60 milligrams of codeine per tablet. But all of them are considered Schedule 3s. And as far as refills go, with the Schedule 3s, you can get up to 5 refills in 6 months. So the prescription is good for 6 months for a Schedule 3, and the doctor can write for up to 5 refills, but they have to be given within that 6-month time frame. So 5 refills within 6 months. Now that same refill requirement and time frame is going to also apply to the Schedule 4s and the Schedule 5s. So you can write that down the line then for Schedule 3, Schedule 4, and Schedule 5, the maximum of 5 refills within 6 months. The prescriptions, again, are only good for 6 months, and if the doctor wants refills, they can have, he or she can write for up to 5 within that 6-month period. All right, so let's go to the Schedule 4s. One of the classes in here of the Schedule 4s are the barbiturates. And the examples are phenobarbital, and secobarbital. If you notice, barb is in the name, so that's it, it's a barbiturate. The next class are the benzodiazepines, Benzodiazepines. The generics on these usually end in PAM, P-A-M. The main example of the first drug, usually that they talk about, is Valium, which is diazepam. So Valium, Xanax, Restoril, and Halcyon are your examples. I'll go over those again. So Valium, which is diazepam, Xanax, Restoril, and Halcyon. Those are your examples of the benzodiazepines. The Schedule 5s are what we call, a lot of those drugs were what we called exempt narcotics. You need to remember the parameters for exempt narcotics. Those were codeine-containing cough syrups that a person could buy 4 ounces of by just signing a logbook, asking for it, signing a logbook. They had to present an ID, and they had to be 18 years old at least. So they could come into the pharmacy. If they were 18 years old, showed an ID, signed the logbook, and by signing the logbook, they were saying that they hadn't purchased any within the last 48 hours. And those were exempt narcotics. Codeine-containing cough syrups, and the maximum was 4 ounces that they could buy. Another example of a Schedule 5, well, I'll give you an example of a codeine-containing cough syrup, Robitussin AC. So Robitussin AC, think of Robitussin added codeine when you think of that. That was an example of a exempt narcotic. Lamodal is an example of a Schedule 5 prescription drug. And if you remember, we used that for diarrhea, but that could not be bought over the counter as an exempt narcotic. But these other ones, like I said, the codeine-containing cough syrups could be bought as exempt narcotics without a prescription. All right, some of the prefixes. Root words. Pneumon is lung. Card is heart. Think of cardiac. Oxy is oxygen. Diastolic is the resting phase in the blood pressure, or the lower number. And systolic is the contraction phase of the heart, and that's the upper number. So when the heart is pumping, the contraction phase is systolic, the resting phase is diastolic, and remember the blood pressure is systolic over diastolic, how it's recorded. And the normal blood pressure is usually seen as 120 over 80. Hemat is blood. You could also write hemo for blood. So hemat and hemo is blood. Derm or dermat is skin. Hepat is liver. Nephro is kidney. I would add ren, R-E-N, for renal. That also means kidney. I also added a couple more. Cyst, C-Y-S-T, for bladder. And remember, if we have a suffix of itis, that means inflammation. Okay, ADME. Remember, those are those pharmacokinetic processes. You learned about these in Chapter 11 and 12 that you just did on Tuesday. So these are pharmacokinetic processes. And by the way, Chapter 11 had a lot of terminology, so make sure you paid attention to the terminology in that chapter. You will see that on the certification exam and on your midterm and final with me, but that's one thing I wanted to highlight in that chapter. So what does A stand for? A stands for absorption. And make sure you know these. A for absorption, D for distribution, M for metabolism, E for excretion. I'll go over them again. A for absorption, D for distribution, M for metabolism, E for excretion. So, and I would know the primary organ for each of these. So for distribution, it's the bloodstream and going to the target, getting it to the target organs. Metabolism would be the liver. And another term for metabolism is biotransformation. Think of the transformers and put bio in front of it. Biotransformation. It's essentially various enzyme processes that are initiated by the liver to break down the drug so that it can actually be inactivated and then either excreted, goes then to the kidney and gets excreted, or we're going to talk in a minute about the first pass effect, and we already talked about that in class, I think about a week ago. And the primary organ for excretion is the kidney. So the organ for metabolism is the liver. Now there are other organs that can metabolize the drugs, but the main one is the liver. And excretion primarily happens with the kidney. Again, there are other organs that can excrete drugs. You can excrete them, blow them off through the lungs. You can, they can come out in your sweat. They can come out in the feces. But we mainly think we're going to focus on the kidney, which is what your book talked about. So that first pass effect is, and we'll talk about the processes in the adult and the child in a minute. The first pass effect happens when the patient is given an oral dosage form, and the liver breaks down a significant amount of that drug because it passes first through the liver before it gets distributed to the target organ. So it first gets in the body. Once it's absorbed, instead of getting distributed, it goes through the liver, has an initial metabolism, and it gets broken down to a certain extent. And remember I mentioned in class, if it's broken down too much and there's not enough of the drug available anymore to the body, we can't give it in the oral dosage form because we don't have enough of it available to the body. And that has to do with bioavailability, which is another thing we went over in chapter 11 and 12. All right, when we talk about adults and children with ADME, in an adult from 20 years old to 70, that is the standard that we base most of the ADME processes in that off of, which being an adult, and dosage, common dosages in that. So an adult from 20 to 70, that's the age range that's considered an adult, and it's sort of the standard at that age of what the function should be, what normal function should be. And we don't adjust for an adult between those unless they have some underlying health condition, because they should be the normal rate of all those processes going on in an adult of that age. Now, when they get to between 30 and 70, those functions of those processes starts to decrease slowly over time, but we still leave them as sort of that standard that we base everything else off of. A child metabolizes drugs faster than an adult. So between age 2 and 12, for a child, that's the age we consider a child, they can metabolize some drugs faster than an adult. An infant and a neonate, all of their processes are still developing. An infant is up to age 1, and a neonate is up to 1 month old. So infant and a neonate, their systems are still developing, but they're actually very similar to the elderly. Because the elderly, their systems are slowing down. And elderly we consider over 70. So we have to adjust doses, obviously, for children and for infants, neonates, and the elderly, because their processes are at different stages. So we don't want to overdose them with drugs, and we don't want to underdose them. So if the processes, say, in an elderly person, if their systems are slowing down, so say their liver metabolism is slowing down, if we give them a drug at the usual rate that we would for a normal adult, the problem would be that we would overdose them. They would get too much of the drug in their system because they're not breaking things down like they did previously because all those systems are slowing down. So we would have to lower the dose so that they didn't get an overdose. In a child that's going to metabolize some drugs quicker than an adult, we'd have to give them a larger dose. Now, this isn't all drugs, but there are some drugs that they metabolize faster. We would have to give them a higher dose so that they would get enough of the drug in their system to get an effect. Otherwise, they would be underdosed. They would not be given enough of the medication. All right, we talked about the first pass, but now we're going to talk about drug-drug interactions. There were 4 different ones that your book gave you examples, and I gave you the examples here. We're going to first start with potentiation. The example was amoxicillin and clavulanic acid, or clavulanate. That makes up augmentin. Clavulanate, or it's also called clavulanic acid, does not have any activity by itself, but when we add it to amoxicillin, it potentiates or makes the effect more than the amoxicillin by itself. So that's an example of a drug that the drug-drug interaction is potentiation. So amoxicillin and clavulanate, or augmentin. An additive effect, the example is trimethoprim and sulfamethoxazole, or you can just write SMZ TMP, which is Bactrim, BACTRIM. Usually it's the DS, the double strength, when it's written. Those two drugs, when they're put together, their effect is the sum of the individual effects. So like an addition problem, when you're adding something to something else, that's what happens when you add these two drugs together. You get the addition, the effect is the sum of both of them together. So trimethoprim, sulfamethoxazole, or you can either write it SMZ TMP or TMP SMZ. It's just abbreviation for the generic drugs that make up that medication. Or Bactrim, like I said, Bactrim DS. Synergistic would be aspirin and warfarin. They give a greater effect when they're added together, and they're both going to cause blood thinning. Warfarin is a blood thinner, and aspirin's side effect is blood thinning. So if you add them both together, you're going to get a synergistic effect, which is a greater effect than them being used by themselves. Just another note, if a patient's on warfarin, or the brand name is Coumadin, and they come to the counter and they're buying aspirin, we have to have them talk to the pharmacist to make sure they're supposed to be on aspirin, because it is going to adjust their blood clotting times, and it could affect their Coumadin or warfarin dose. So we have to make sure the doctor wants them on it, and they're not just buying the aspirin, say, for pain relief. Because remember, aspirin by itself is an analgesic. It has a couple other effects, but it is an analgesic, but one side effect is the blood thinning. An antidote, this would be for an overdose of something or poisoning. The antidote in question is going to be Narcan, or naloxone is the generic. So Narcan and heroin. So if you give Narcan when a patient is overdosing on heroin, it's going to block or decrease the toxic effect. It's going to bind the receptor, and it's going to, in the case of Narcan, it immediately stops the euphoric effect and the CNS depression of the heroin. Another antidote, again, we'll talk about warfarin. It's warfarin and vitamin K. So if the patient has, their blood is too thin, we give them vitamin K to reverse that effect, and it regulates their clotting time, and it makes the blood thicker, essentially. So vitamin K and warfarin to decrease the thinning, so that it makes the blood thicker. So it's not, we decrease the blood thinning effect and regulate their clotting time. Drug-diet interactions. Tetracycline will interact with calcium-containing products, so we can't give it with milk or with antacids or with calcium carbonate. We have to watch that. We space it out 2 hours. That's the golden number, is 2 hours. So you can give them the tetracycline, then 2 hours later they can have a calcium-containing product. Tetracycline should also not be given with iron. And like I mentioned, antacids. So some antacids have calcium in them, but also antacids with magnesium or aluminum. It'll bind that. What happens is it binds the calcium or the iron or the magnesium or aluminum, and it forms a complex that can't get absorbed. And so the tetracycline, you're not going to get any effect from the tetracycline, and it's actually going to come out, be excreted in the feces in this complex that it forms. So the patient isn't going to get the effects from their tetracycline. Another drug-diet interaction is metronidazole, or Flagyl, and it interacts with alcohol. So when the patient, while they're on metronidazole, usually they're on it for, say, 7 or 10 days, they cannot drink any alcohol, and they need to wait an additional full 24 hours after they're off it for it to be out of their system. And what happens is they get a disulfiram reaction. And I'll spell that. disulfiram, where they actually get sick from the alcohol. So they'll get nauseous, they'll possibly start vomiting, they'll have blood pressure effects, they just get very, very ill from it. So that you do not want to give them anything, you do not want to have them drink any alcohol when they're on that. Another food-drug interaction is with warfarin are green leafy vegetables. So collard greens, spinach, kale, those types of items, and there's some other ones. You do not want patients that are on warfarin to have those because they contain vitamin K and they will affect the clotting time, so they'll make the blood thicker. And if they're on warfarin, they need the blood to be thin, so they need to watch their diet with those types of foods. And then I know I skipped over MAOIs. Those are a type of antidepressant. And what MAOI stands for is monoamine oxidase inhibitors. I'll say it again. Monoamine oxidase inhibitors. And what patients can't eat with those are tyramine-containing foods. Tyramine containing foods. Those include aged cheese, beer, red wine, some like sausages. These things contain tyramine and they will interact with those drugs. I'm going to stop the presentation now, and there'll be a separate one for the remaining, I think we have 3-4 more pages. I'm going to figure out what I'm going to do with the calculations, though. I'm going to try to do that as interactive as I can. It's hard to write with a pen on here. I'm going to see how I'm going to do that, though. So you're going to have to listen to multiple recordings, but I don't think you can sit for hours at a time anyways listening to me. So there will be another one. I will post these all on Blackboard under course content. So make sure you look at these. And again, I just want to remind you the midterm exam will be on Tuesday. I'm going to open it up at 5:30. You'll have 3 hours to take it, so it'll be open between 5:30 and 8:30, and you will take it online. All right, I will do the second one, and I will post that separate.